All right, well, I guess we can just do a little introduction here. My name is Analies, and I'm Hydroviv's head of policy. And then we have...
And I'm Eric. I'm Hydroviv's founder and I guess chief scientist. So yeah.
Today, we're going to be talking about chromium-6. And we've been getting a ton of questions on support and email about chromium-6. It's still a very present drinking water contaminant. A lot of people think that it was, just 20 years ago during the Aaron Brockovich movie, but it's still very much in drinking water in 2020.
It's really, really interesting just to see how public awareness of certain contaminants kind of comes and goes in waves because, I remember, I think it was back in 2017 or something, like chromium-6, I think Environmental Working Group did a piece on it or something, and it just got we got a ton of volume from that, like in terms of chat.
Yeah, absolutely.
Yeah.
So, I guess we can just get right into it. So, Eric, let's kind of just talk about chromium-6. What is it? What it's used for, and just kind of a brief overview of what we're going to be talking about today.
Yeah, absolutely. As is the case with a lot of these contaminants that are toxic, they're also very useful chemicals. That's why they exist. That's why we produce them. Chromium-6 in particular, it's something that's used in anti-corrosion, in leather tanning and metal plating and all that type of stuff. So it's something that's used all over the place, and we'll talk a little bit about an example that took place at a decommissioned metal plating plant in Michigan just about a year ago, and we can talk a little bit about that. But yeah, it's a useful chemical, has useful properties, but when you use a chemical and you don't dispose of it properly, it ends up in the environment, just like with PFAS and stuff like that. Yeah. Chromium-6 is no different. So yeah, it's just something we wish we were there. We wish it was one of those things that was easier to remove at the municipal level and at the whole house level, but it's something that's nasty. You don't want it in your water.
Yeah. So I'll kind of take the next question that we get quite frequently is just
and Annalise, I forgot to say something real quick. I'm thinking back to like the questions that we get asked a lot. Chromium-6 is a specific type of chromium. So it's hexavalent chromium, which is different than trivalent chromium. Regular chromium, so chromium metal, is not super toxic. Chromium-3 is not super toxic. That's what you typically find in like stainless steel pans and stuff. Chromium-6 is just this super toxic, if you want to call it a chemical flavor of chromium, and it's super, super toxic. So it's not the same stuff you see in the dietary supplements. It's a different chemical.
Mm-hmm. Yeah. So why should we be worried about it? I'll kind of take this one. So there's a lot of really well done research on inhalation of chromium-6 in the workplace, but people kind of ignore drinking water, which is why it's not currently regulated by EPA, despite the fact that it's kind of been in the regulatory process for so many years. It's been on the unregulated contaminant monitoring rule list multiple times. And this is kind of the funnel for getting drinking water contaminants regulated by EPA. So despite all of that, NIH has determined that there are clear carcinogenic effects and that it should be classified as likely to be a known human carcinogen in drinking water. So like I said, it's not regulated by the EPA, despite NIH kind of saying, we know that it has carcinogenic properties, and we know that it has caused cancer via ingestion of drinking water in the past. So
yeah, I can shine a little bit more on that. So I remember my first water quality lab that I worked in. I was an undergrad, and in any chem lab you have like the safety talks, right? It's like, okay, do this is safe, treat it this way, this is not safe. I remember chromates, so a type of chromium-6, those were actually held in a specific cabinet where it's like, okay, this is pretty benign stuff like the table salt. Then you have the toxic stuff that's, you know, the normal toxic stuff, but the chromates were on their own. Those, we were calling those like super toxic chemicals. Just, it was one of those where you just don't want exposure to them. So yeah.
Yeah. Yeah, so we kind of answered this already, but I guess, Eric, maybe you can shed a little bit more light. So one of the things that I think we get a lot is there's a misconception, as you said earlier, that chromium includes chromium-6. So right now, like, chromium is regulated by EPA. Yep. It's 100 parts per billion. So that means that water treatment facilities have to reduce chromium levels to 100 parts per billion. So when people, it's really confusing because when people,
which is really, really high. Like there's very few places that are going to have that much chromium in their raw water.
But when people see that, they think chromium-6 is encompassed in that. So yeah, I mean, how do we kind of tell people that, or shed some light on this? Like, how do we differentiate the two?
Yeah, that's a really good question. So on the water quality reports, again, we're openly critical of EPA and the regulatory list, and particularly those chemicals that are not regulated specifically. So yeah, total chromium is regulated, and that's what, if you go to EPA's website and you punch in chromium-6, you'll see, oh, it's regulated as part of total chromium. But that limit, Annalise, you said it was 100 parts per billion, is that correct?
Yeah.
Whereas chromium-6 is toxic at part per trillion levels, so like 1/1000th of that level. You know, I think you'll talk about that in a little bit, the toxicology side, but
yeah,
in my mind, there's no good reason why it's not regulated outside of the cost of doing so. But you know, as we always say, it's just so important for the public just to be, even if it's not regulated, it's just so important for the public to be aware that it's toxic.
Yeah, absolutely. And that kind of goes into the next question of what is a safe level of chromium-6 in drinking water. And this is still, it's wild to me how controversial this is, specifically because of the cost and the municipal burden that it would put on municipalities if it was such a low level. But I'll just kind of talk about one particular case study, which is the state of California in 2017 actually set a state maximum contaminant level for chromium-6. And it was super, super small, 0.02 parts per billion chromium-6 in drinking water. But the California Water Board was actually sued over this level because they didn't take cost into consideration. So the regulation, you know, I want to say it was like a year later, was completely redacted. So yeah, I mean, it's still, we have no idea really what.
It's really, really, really toxic. And, and I understand why the water, you know, like the municipalities and the California Water Board don't want that to be a limit, because you cannot achieve that at the municipal level without an obscene amount of cash. And it just doesn't make sense. You don't need the water you flush your toilet with to be lower than 20 parts per trillion. It's not, you know, it's just not where the risk is. You just don't want to put it in your mouth, you know? Yeah,
totally. And then Eric, you can kind of talk about this next one, and, you know, what are some of the hot spots, and then I'm sure everyone would love to hear about what happened in Michigan. Those were some pretty intense images. So.
Absolutely. So I apologize if you can hear my dog's toenails in the background. Nana is pretty active right now, so she's trolling around. Hotspots, yeah. I mean, a lot in California. Not surprisingly, that's where Aaron Brockovich, that movie was kind of, you know, was set. Arizona, New Mexico, we see it in Oklahoma. It tends to be higher, and it tends to be a bigger problem in groundwater than surface water, just because surface water, like rivers, it tends to kind of get swept away more quickly, whereas in groundwater, there's nowhere for it to go because it's already in the ground. So if you have something feeding, if you have a contaminant stream feeding into your groundwater, you know, it's just going to accumulate. So yeah, Oklahoma, I think we see a lot of it in Arizona, New Mexico. We have a lot of California customers that it's off the charts as well. Yeah.
Yeah. Yeah.
And then you had brought up, we had both brought up that chromium 6 spill in Michigan. So this was really interesting. I actually got flagged this because I know the hazmat team that was actually called to respond to it. All right. So I kind of get a text with some pictures from some of my hazmat guys, and I'm just like, I don't know what's going on there. Then they took pictures of the lab, and I was like, well, that's so basically what had happened. If you look in our Instagram stories, you'll see some pictures of just like this green slime kind of going all over a highway in Michigan. Basically what had happened is there was this decommissioned metal plating facility that was essentially set up in a giant shed, and they were just dumping all their metal plating waste into a pit. So if you removed floorboards, you could see a pit, and that's where they were discarding all their heavy metal waste. And when you dump it into the ground, it ends up in groundwater, and basically it caught like this culvert or drainage ditch and ended up spitting out on the highway as this green like sludge. And for chromium 6 levels to be high enough that you can actually see them, I mean, it's a hazmat scene.
Yeah.
Let alone the impact that they said that groundwater and drinking water wasn't impacted, but I have a hard time believing they actually sampled every well within a multiple mile radius of that place.
Yeah.
It was in a part of the state where there's people that drink from private wells.
Totally.
Yeah, it was bad news. But.
Yeah, we have the article that was written about it in our link, so feel free to check it out.
It was like right before Christmas, right?
Yeah,
if I'm remembering correctly. I seem to remember us like scramling to get this out.
Yeah, I remember
before we were
texting
spending
me
time
the
with our
images,
families last week.
like I think the day before Christmas
staggering.
Eve or something.
Yeah.
And I was like, this doesn't look like it's real, just because you don't think of water
Right.
pollution being that green and yeah. So so this is a really common question, and it just kind of touches on TDS. So I know, and we actually did have someone write in asking this. So can you measure chromium 6 via TDS?
I wish these TDS companies would just go away. I really, really do. The answer is no. You can't replace laboratory measurements with a $7 test stick. It's just not the case. Let me talk about why. So a lot of the proponents of TDS meters, they say, well, chromium 6 is inorganic, so it can get caught by a TDS meter. I'm like, but you got to remember, a TDS meter is measuring every inorganic contaminant at part per million concentrations, whereas chromium 6 is really, really toxic at very, very low part per billion and part per trillion concentrations.
Right.
So by the time you would actually see you would see a rise in TDS, even if you knew it was all chromium 6, the water is so toxic that it's not a meaningful measurement. It's even worse than that in real life, because a TDS meter, you have no idea if that number on your TDS meter is from calcium, magnesium, or anything else. So it's in almost all cases, it's all calcium and magnesium, because you're just measuring the mineral content of the water. Chromium 6, a TDS meter is completely worthless for that. Chromium 6, because it's a type of total chromium, you kind of have like those cheap home kits. Then you have the next tier up of laboratory testing where you're doing like elemental analysis, like with an optical ICP or an ICP-MS. And even those instruments aren't the best tool for the job for chromium 6, because they look at total chromium. So you actually need to do something like ion chromatography or something to actually separate out the chromium 6 from the total chromium, from all the minerals and all the background interference. And that's a really expensive test. There's no way around it. Most homeowners are not going to do that test. It's not going to be part of your standard well checks. Mm-hmm. Most analytical labs don't even offer that as a test. So if you go to your accredited water quality lab and say, hey, I want a chromium 6 measurement, they're probably going to sell you a total chromium measurement that's done by ICP. They're different things. So you really need to make sure that if you want to measure chromium 6 in your water, you've got to make sure that the lab is using an EPA approved method to actually measure chromium 6 and not total chromium. But yeah, TDS meters, just, I wish they'd go away. I really, really do.
Yeah, that's a really good, just kind of,
Yeah,
if you
go
take
there.
if you take one thing away from this, it really is that total chromium is different than chromium 6, and that they can't be in the same category. So then we also got this question: does boiling your water remove chromium 6? The answer to this is no, as well. So this is a really common misconception, and we've been getting questions about this regarding PFAS and lead as well. Just because I think there's a misconception that boiling your water will remove everything, or boiled water is completely free of contaminants, and that just couldn't be the case. So boiling your water does remove biological contamination.
Yeah, it kills bacteria.
Yeah, bacteria and some viruses, but not chromium 6, not PFAS, not lead, not arsenic, not things of that toxic nature.
No.
All right, so how do we remove it? We've learned all of this stuff about why it's bad, where it is in drinking water. How do we remove it?
Okay, so there's a couple different ways to do it. If you're using, you can do it via reverse osmosis. Proper pretreatment. Oh, looks like my internet is failing here.
There we go. You look back.
Okay, so I think I'm back. All right, sorry about that. So yeah, you can definitely remove it using reverse osmosis. If it's a good system, it'll probably do it. So Culligan makes a good system, APEC makes a good system. That'll remove it. What we do at Hydroviv, because we don't use reverse osmosis, is we use like a type of activated ceramic that does a really nice job on it as well. You can do it, you know, alumina and titanium will do a pretty good job on chromium 6 as well. There's also some anion exchange resins that do a pretty good job on it as well. And the reason why you want it to be anion exchange is because chromium 6 in drinking water doesn't typically exist as like Cr6+. It actually shows up as chromate, which is negatively charged. So some of the anion exchange resins work as well. There's a couple different ways to do it. Carbon does not do it, so you want to make sure that you're getting a filter that's actually been tested specifically against chromium 6.
So what about like Brita pitcher filters, things like that?
No. If you're using just a carbon filter, or even just like a pitcher that's rated for lead removal, it's not going to get chromium 6. You really need those specialized ceramics in there. They're expensive. Most water filter companies don't do it because most people, you know, chromium 6 is not on their radar, so they're not asking for it.
Right.
You really need a system that's been designed for chromium 6. So,
right.
Yeah.
All right. Well, awesome. So just to kind of recap everything, chromium 6 is still very much a problem across the country. And it's not regulated by EPA, so municipalities aren't required to remove it. Not all water filters remove it. And yeah, you can't measure it via TDS, and you can't boil it. So yeah, we have some really good resources in our link in our bio where you can learn more about chromium 6 and kind of recap more of what we talked about today. But yeah, I think that's pretty much it. So
how do people get in touch with you if they have questions?
Yes. So you can always message us on Instagram, or send us an email at hello@hydroviv.com, and one of our support team members will send that over to me or someone else who can answer any of your questions.
Yeah, and if you have a question, you can also just DM me at this handle, Hydroviv. And I answer a shocking number of water quality questions through Instagram. So happy to do that. It might just take a couple minutes, so I usually kind of take care of them at night. So Excellent.
Cool. All right. Well, thanks for joining. Bye.
Bye, everyone.